Welcome, everyone. Grab a seat and let's get started. Welcome to today's Public Health Seminar, an explainer brought to you by the Research Department of the Fountain Bridge Initiative. I'm absolutely thrilled to be your professor today. We're going to explore a fascinating, if maybe slightly unsettling topic that completely shapes global health. We are talking about soil-transmitted helminths, or STHs for short. Basically, these are ancient microscopic hitchhikers that have been coexisting with and, well, feeding on humanity for millennia. To really understand why we dedicate entire research initiatives to this, you just have to look at the sheer scale of the issue. Think about this number for a second, 1.5 billion. Right now, up to 1.5 billion people are infected globally. That's roughly 1 in every 4 individuals on the entire planet. And this is not just some benign, harmless coexistence. These infections cause an estimated 135,000 deaths every single year, and it disproportionately hits the most vulnerable communities among us.
All right, here's our syllabus for today. The global parasite problem, life cycle and transmission, symptoms and diagnosis, the economic burden, breaking the infection cycle, and we'll wrap up with global elimination strategies.
Part 1. The global parasite problem, an ancient, invisible enemy. What exactly are we up against when we talk about these neglected tropical diseases? So, soil-transmitted helminthes, STH, is really just an umbrella term. We're talking about a group of intestinal parasitic nematodes. The major culprits you need to remember are roundworms, whipworms, hookworms, and threadworms. Now, unlike malaria, they do not need an intermediate host like a mosquito. They are transmitted directly through soil that's been contaminated by human feces in areas that lack adequate sanitation. At its core, this is a disease of poverty. It thrives exactly where clean water and toilets are scarce. Moving to part 2, life cycle and transmission. The microbiology lab. Because to defeat an enemy, you really have to understand how it lives, breathes, and multiplies. The transformation process is what makes these parasites so dangerous. First, you have the rhabditiform stage. This is the non-infective early stage right after it hatches in the soil. But wait about 7 days, and it molts into the infective filariform stage. At this point, if a human walks barefoot over that contaminated dirt, this microscopic larva actively burrows right through their intact skin to get inside the body. It is an incredibly efficient, stealthy biological mechanism. And man, are they prolific multipliers. Take Ascaris, the giant roundworm. Just one single mature female living inside a human intestine can pump out up to 200,000 eggs a day. 200,000. Those eggs are shed out into the environment where they just hang out in warm, moist soil, waiting patiently for someone to ingest them through contaminated food or water. Now, tracing the journey of the Ascaris parasite once it gets inside a human host reveals biological mechanics that are equal parts fascinating and, frankly, terrifying. Because it definitely doesn't just stay in the stomach. Let's break that journey down. Once you swallow an embryonated egg, the larvae hatch in your small intestine. But they don't settle down yet. They actually bore through the intestinal wall, hitch a ride in your bloodstream over to your liver, and then up to your lungs. Once in the lungs, they break out into the air sacs, migrate all the way up your windpipe where you naturally cough them up, and then you swallow them right back down. They finally return to the small intestine to grow into foot-long adult worms and start producing those 200,000 eggs a day. Let's look at part 3, symptoms and diagnosis, the clinical reality. What does this internal tissue-migrating invasion actually do to the human body? The physical toll is brutal, especially for preschool kids and women of reproductive age. Because the worms literally feed on host tissue and blood, moderate to heavy infections lead to chronic intestinal blood loss and severe iron deficiency anemia. These worms are actively stealing nutrients like vitamin A, which causes malabsorption, diarrhea, and in children, significantly stunted physical and cognitive growth. And remember that lung migration phase we just talked about? That can even trigger pneumonia-like respiratory issues. So with symptoms this severe, you've got to wonder, why is this so hard to track and diagnose globally? Well, for starters, light infections can be totally asymptomatic, but there's also a massive diagnostic hurdle. Take the threadworm, Strongyloides stercoralis. It requires completely different laboratory methods to detect compared to the other worms. Even worse, its larvae can hatch inside the bowel and immediately repenetrate the intestinal wall. It endlessly auto-infects the host without ever leaving the body. Because our standard everyday tests miss it, it frequently goes completely unidentified by doctors in endemic areas. Part 4. The economic burden, a cycle of poverty.
We can't just look at STIs as a medical problem, because it is a profound economic burden. It's all connected. Childhood anemia and physical weakness directly lead to missed school days and permanent cognitive delays, totally robbing kids of their future potential. In adults, chronic fatigue and malnutrition destroy labor productivity, which hits agricultural communities especially hard. And when severe disease strikes, families are slapped with catastrophic out-of-pocket medical bills. This parasite doesn't just feed on the body, it feeds on the economic vitality of entire communities, locking families in a generational cycle of poverty.
Part 5. Breaking the infection cycle. Public health interventions. As public health professionals, how do we actually snap this invisible chain? We've essentially got two main weapons. On one hand, there's mass deworming, giving preventative chemotherapy to entire at-risk populations. This is absolutely vital. It gives immediate relief by killing the adult worms and stopping the severe anemia and stunting. But medicine alone is a vulnerable strategy. If we only rely on constant chemical deworming, we run a very real risk of the parasites developing drug resistance. Plus, taking a pill today doesn't stop you from getting reinfected tomorrow. That's why wash interventions, water, sanitation, and hygiene are the ultimate cycle breakers. Clean water and toilets physically stop the eggs from ever reaching the soil or the host in the first place. And the beauty is, it doesn't take high-tech solutions to make a massive dent. Essential wash practices, things like building basic latrines for safe waste disposal, treating drinking water, simply wearing shoes so hookworms can't penetrate your feet, and washing hands with soap, these can slash the odds of STH infection by a massive 33 to 77%. It's that simple. We literally cannot medicate our way out of dirty water. Finally, Part 6. Global Elimination Strategies, the report card. Let's look at where international efforts actually stand in wiping out these ancient parasites. Momentum has really been building for decades. Back in 2001, the World Health Assembly passed a landmark resolution to finally mobilize control resources. By 2020, programs were successfully treating over 450 million school-aged kids every year. And just recently in 2024, recognizing that hidden threat of threadworms we talked about earlier, the WHO published its first ever public health guidelines specifically targeting strongyloidiasis. Just let this number sink in. In 2023 alone, mass treatment reached over 457 million people. That is one of the largest, most coordinated public health interventions in human history. It's incredible. But as we've explored today, handing out millions of pills is just a continuous treadmill if the environment they live in stays contaminated. Which brings us to this powerful reality check from the WHO guidelines. They state, long-term solutions to soil-transmitted helminthiasis require improvements in water, sanitation, and hygiene. Multi-sectoral, integrated programs will be needed to maximize and sustain the benefits. We have to treat the environment exactly as aggressively as we treat the patient. I want to leave you with this thought to chew on as we wrap up today's seminar. We understand the biology, we've got the medicine, and we know for a fact that clean water is the ultimate cure. So what role must cross-sector collaboration, really combining the health sector with civil engineers and infrastructure, play in our future to permanently eradicate these parasites? Until we build systems that protect human dignity through basic sanitation, that invisible chain is going to remain. Thank you all for joining me in the lab and the lecture hall today. Stay curious and keep learning.